That's enough.
I believe we're on, gentlemen. And happy holidays,
Okay, you're
everybody.
on.
Happy holidays, you stargazers. It's a good time of year and a great week to be checking out the night sky. I am Ronnie Heron from the Santa Barbara Astronomical Unit, Santa Barbara, California's longtime telescope and astronomy club. And this is the SBAU Astro Hour again, live from our homes of the Brain Trust around me on the screen. Seen live every week, Monday mornings, for over 4.5 years now on YouTube. And we just love getting together to talk over our favorite science topics. A lot of cutting edge cosmology here, folks. New discoveries, new comets, new celestial photographs cropping up. And this will be episode 252 for December 22nd through the 28th. That's Christmas week. 4.5 years now on YouTube. Right. I wonder why this guy's wearing a Santa hat. If you're interested in a good, fun club, you want to join us, just come start with SBAU.org and then come to a star party or a first Friday meeting. And we're going to have a week from this Friday. Dr. Martin, Crystal Martin of UCSB, taking us to the early galaxies. Here's what we're talking about today, our journey into the heavens, tell you about the winter solstice, which just happened yesterday. Dark skies this week, just 3 degrees east of Deneb. The Swan's brightest star is NGC 7000, the North American Nebula. There's a big camera with a 48-inch aperture at Palomar Observatory down in San Diego County, named after a guy named Schmidt. We got pictures. It's time for one last meteor shower this year. The Ursids will close out the year. Comet 24P Shamazi is at magnitude 11, rising around midnight. We'll update you on our newest interstellar visitor, Comet 3I/Atlas. Got an update on our nearby dwarf planet. It's in the asteroid belt, and plenty of Christmas stuff out there, much of it contained in NGC 2264. Ho, 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 you bet your sweet magnitude 1.2 fomalhaut. We're going to have a good time. Let me introduce the good time rebels, the president himself, reelected for a 9th term, my good friend Jerry Wilson.
Good morning, everybody, and good morning to my grandkids, Riley and Calvin. Calvin just spent the night here with me, and so.
What about the ladies you usually say good morning? I've been watching.
What's that?
I'm sorry, what did you say, President?
I was saying, what did you say?
I asked you about, isn't it ladies, different women? Did you just welcome aboard your grandson?
Yeah, and my sister. I didn't mention my sister, Joyce.
That's what I was asking. Can't do the show without Joyce, for crying out loud. He's married to Pat Forgy, and the Forgy Wilson company is one of my favorites. I've invested in them. Here is our incredible outreach coordinator, Chuck McPartland again, front of the Ukraine flag. The cats, I'm sure, are wearing little Santa hats once they show up on screen. He's married to our incredible merchandise manager slash treasurer, Pat McPartland. I wonder if she'll ever sell out, and then we won't have to need her service 6 to 6:30 on a Friday night first party. And doggone it, if here is not our good friend Tim Crawford, lens and telescope expert. And
hello.
Our December speaker in 12 months. and we have some, I guess Tom Whittemore may join us, or he's probably shopping at Costco for.
I sent him a text. I haven't gotten a reply, so he might be somewhere at an appointment that.
He's socially active this time of year.
Yeah,
I sent him a text too, so he's getting bombarded.
Okay, well, if he joins us.
Oh, there
he is. Here he is right now.
Hi, Jerry.
Morning, Tom.
Hello,
Hi, Tommy.
Hi, guys. Got lost in my broccoli soup. I'm making a broccoli soup. Thanks,
Right.
Chuck. Thanks, Chuck.
Tim Crawford is married to Karen, and my friend Tom Whittemore, former Westmont College science professor, is married to Maureen. And in case you haven't heard, we have some sad news about our normal 6th.
Yes, we found out just a few minutes before we went on the air that our frequent contributor to this program, Bruce Murdoch, yes, is that he passed away on the 18th.
Wow.
And so we have not had our thoughts together yet. We're all shocked with that. So we will have a proper eulogy for him next week to begin our show.
Yeah, my gosh.
Yeah. So anyway, his wife Bonnie called me, and
I
They
see.
will have no services in the immediate short term, but somewhere in late January, early February. So
Man
Bruce,
was
we miss you very
knowledgeable.
much.
He was a mentor to me, and I got stuff to say about him. He'll be missed. I guess his daughter came and shaking over
Yeah.
things out there. So you're the last to know, Tom, and
Yeah.
good to have you on board. And your lovely wife is Maureen. I guess we're ready for the silly cartoons,
Okay.
which were sent to us by the president and gets us all going. You want to read this, Jerry?
The world's most advanced computer once took 7.5 million years to give us 42. Let's not rush.
The rest of you understand that?
I don't.
That's
Good.
probably
That's good.
from Galaxy.
Yeah,
Hitchhiker's
Hitchhiker's
Guide.
Guide to the Galaxy.
Yeah.
They
We're saying the Galaxy was a computer?
Yeah, well, they made a computer, yes. It was,
No, 42 was the answer to everything.
yeah, life, the
Oh.
universe, and all that.
Was 42?
Yeah, and then at the end, someone said, well, wait a minute, 42, what does that mean? And then the computer said, well, that's another question. And said, in order to answer that, we're going to have to make a new computer that will involve human elements, and we'll call that computer Earth.
Earth. Tom Whittemore, do you understand this?
No.
Okay,
Well, great. I'm glad. Okay, these are the terrible germs surrounding a molecule of food on the floor. Once you drop it, usually face down with the butter or the peanut butter facing. Count. You got 5 seconds.
yeah, this is the famous 5-second rule, which
Yeah,
I
right.
was introduced by my young kids about 20 years ago. I'd never heard it when I was a kid.
I can't tell you how many times I've done that. Well, if I grab it fast, it'll be
Yeah.
okay.
So I was in a theater one time with my kids, and we had popcorn, and a popcorn flipped out of the box, and I saw it land on the floor, and I reached down and picked it up real quick, and I popped it in my mouth. And my kids go, ew. I said, what's wrong with that? It was under 5 seconds, and my daughter handed me one, and she said, Dad, this is the one you dropped.
Oh.
What people don't know is that you've got hoof and mouth disease right after that.
I got one, Jerry, on that. I was in our dental lab, and I had a crown in my hand, and I handed it to a dentist, and it fell on the floor. And I said, "Do you use the 20-second rule?"
Put it in quick. Okay,
And depending
who
on the
wants
depending on the theater, you're lucky if you could pick it up off the floor.
right. A lot of gum down there, I'll tell you. Who wants to do this one? Chuck, you think you can interpret? You saw these.
Sure.
already.
Scientists say they can recreate living dinosaurs within the next 5 years. And
Oh
the
my
comment was, there are literally 4 movies showing why this is a bad idea.
Bad idea.
Yeah, well, Steven Spielberg.
I finally got this. Took me
All
a
right, then you get to do it, Tim. What the hell is going on? It's a
Well,
cuckoo
you
clock.
know, the clock struck 12, and that little
Yeah.
door at the top, it flips open,
Right.
and the fly didn't know it.
And now he
Oh,
doesn't
I
care.
thought it ate the cuckoo or some sort of a
No.
predator.
No, he's flat against the wall.
I see.
We had
Okay.
a
Great.
cuckoo clock when I was a kid. My mother loved them. And my dad claimed that it comes out every hour and gives its comment on the family.
Yeah.
Does it do it overnight when you're sleeping?
Yeah.
Yep.
Every hour you got a cuckoo and you can
Yeah.
sleep through that.
Some of them,
Well, it was in the
some of
next
them do it
room.
every 15 minutes.
Yeah. Well, no, we had an hourly one.
Well, that's good.
Right. Okay, Whittemore, did you see this one? You want to, two dogs are talking?
Marking out our territory on the moon is going to be a huge technological challenge. Yeah.
That's our furry friends, the dogs.
Yeah, they're going to be wrapped up in spacesuits.
Right.
I didn't get that the first
Yeah.
time around.
Yeah.
Well, it's about time. All right, Mr. President, I can barely see this.
Is it
What are I
faded?
doing?
It's,
I didn't
it's okay.
It's all right.
This wasn't part of yours, was it? That you sent us?
No, this is a separate one.
Okay,
Let's
there.
point the telescope toward one of the pinnacles of human achievement, the space station. And
Oh,
there's
the
this
guy's
guy
picking his
outside
nose.
picking his nose.
Oh,
The picture on the right is what he's seeing. All right.
Now, this is my favorite one. It's so obvious.
All right. Then read it to us.
Santa is a quantum being. His probabilistic nature means he can be in every house at the same time on Christmas. That's why it's vitally important no one sees him. If he's observed, the probabilities collapse and only one house gets presents.
Oh God.
Or he's
Corny
dead
as hell, but
inside.
very good.
He's in Schrodinger's kitty cat box, dead. One or the other. Okay. Is there any more? That gets us in the mood.
Oh, wait, there's one more.
Oh dear. Okay, this is the one that's going to stump us. Oh yeah, this isn't a funny one, but it's, or maybe it is.
It's got some funnies in it. This is a telescope type. Prime focus, Herschelian, Newtonian, Galilean, refractor, Keplerian, there's that, Gregorian with a concave secondary, Cassegrain with a convex secondary. Here's the liquid mirror with a straw and some lips so you can suck out the liquid. However, the liquid would be mercury, so I wouldn't recommend that.
No.
There's a simple cardboard tube, which is where I started.
Really? Built your own?
Yeah, you just hold it up and look through it and
My
use your
favorite's
imagination.
My favorite's the Kaleida.
Yeah, Kaleida.
We
Yeah.
all had one of those.
And here's the Narcissian.
Oh, now I get it. I looked at that. I couldn't figure it out.
I
Here's
still
the
don't get it.
the gravitational scope. There's a black hole right there. So it's
Okay.
gravitationally focusing the light.
Okay, and then
And this is
geologic.
geological. TV playing the core, 2003. So this is a television. Now I don't get this one. So if anyone can help me, it must be some show.
Well, it was a movie about digging down through the mantle and going to the core of the earth.
Really? That's pictured in that one?
Hmm.
Well, since there's no movie connection, I offered up the Cinerama version from Hollywood. Remember the Cinema Scope? Widescreen.
Oh yeah, why not Cinerama?
Cinerama, yeah.
CinemaScope. Yeah, I remember that.
Yeah, it was in 3 parts. You could see how the West was won. Remember that? Good
Mhm.
Lord.
Well, that was a long time ago.
Glenn Ford on the right side and John Wayne on the left and wagons in the middle. I only went once. That was all I needed. Well, that was entertaining, and we miss Bruce, and
Yes.
we may need to replace him with somebody. Maybe we can get Tom Totten back. Okay, what is this?
Stonehenge.
Stonehenge. Okay.
This is a picture I call Druid Winter. This is
No, I really like this. I've never seen this aspect.
I never have either, but it's not quite lined up. There's the sun, there's that. That should be in a straight line with this. But I
It's
know
a couple of days early though.
yeah, it was taken on the 19th, not the 25th. And I think it's sunset, not sunrise, but
Yeah.
that shouldn't matter. The but I think that in England they probably didn't have this was the clearest sky they got.
Yeah.
Actual date.
And
Yeah.
plus, this is 5,000 years old, so there's been some procession. So
That's true.
I think it's actually 4 minutes late now.
Yeah, I
Really?
started counting all the pillars and I was wondering if those just are kind of the months.
Are there 12 of them?
No, there's more than
There's
that.
11.
Oh,
When it first went up, it was pretty neat and organized, I think.
Well,
Yeah.
now I see 10.
Well, it would have to be all the way around the circle too, Tim.
Oh,
that's
yeah.
well, you're alluding to one of the things that cracks me up when I read that the pyramids in Egypt are aligned with Polaris.
yeah.
Yeah, yeah.
And they were
Right.
built 5,000 years ago or 6,000 years ago, and Polaris was not our pole star then.
It wasn't there.
Well, I read that it was just aligned north and south exactly. Maybe that hasn't changed much. Probably
Well, no.
has.
No, it's the line that was north and south has changed.
Yeah.
Is it really?
Yep.
It doesn't fall upon a longitude line. It would be slightly off.
No, the Earth as it spins around, figure my think of my finger as spinning madly every 24 hours. But as it goes around in the orbit of the sun, this whole plane rocks slightly. It precesses, and the North Pole of the Earth moves around and describes a circle on the sky that is, as if I recall right, either 12,500 or 25,000 years.
26,000, yeah.
6,000, okay.
But you're talking about the polar axis, not the magnetic one?
Yeah, the spin axis. What is our North Star?
Yeah.
12,000 years, it'll be Vega.
Well, regardless of where the stars are, the polar axis would stay the same, wouldn't it?
Yeah,
Wouldn't it?
you're right, Ronnie. Yes, you're right.
So they could align along that polar axis, and I'm sure there's a longitude line that goes from the North to South Pole and right past, or maybe through the pyramids.
But they thought the North Star at that time, it was Thuban, was the portal that the souls had to get to. And so they had a window that pointed toward that. And that would be at a slightly different altitude.
Do you suppose we had a bear back then, a Big Dipper, or was it?
Sure, of course, yeah.
There was a Big Dipper. It just okay.
Yeah, but Polaris was not the North Star then.
Yeah.
Right. Okay.
Here's a good one, an aside for you, Ronnie. I took the picture of the Big Dipper, and I wanted to know which way that the stars were migrating, which direction they were going. And I think most of them are going in one direction. So the Big Dipper doesn't change much. So I took my star program and I fast forwarded, I think it was 500,000 years, and it still looked just about the same.
There's
It
one
hardly
star in
changed at
there
all.
that really takes off.
Yeah,
Yeah.
one of them did.
Yeah.
Yeah,
But
the very tip of the bowl and the very tip of the handle are going in different directions.
different directions. And those two changed, but not that much over that long period of time.
Well, how long has mankind had ladles that look like a dipper? Is that something new? They make
That's
them out
probably
of
pretty
wood,
old.
are they?
Yeah, it was a wagon to the English, right?
Yeah.
Mhm.
Wow. Okay, to the night sky we go, ladies and gentlemen.
Yes, this is the horizon at about 8 o'clock. Now, at our place, it's definitely dark by about 5:30 or 6. So no problem seeing this at night. It's in the west, northwest. There's west over there. So these are coming around the pole star and they're setting. The pole star is right up in that region.
Mhm.
So they're rotating around, and this is the constellation of the Swan, Cygnus, with Deneb up here.
Mhm.
And around that, up here in this region, is a very faint nebula, the North American Nebula and the Pelican Nebula, which on a real dark sky, if you're looking out from here, if you're looking out over the ocean, you stand a good chance of seeing it because there's no lights out there. You won't see it like this.
Yeah.
This is a image
Whoops, really,
taken.
it jumped to a really washed out version, but you can
Oh.
still see it.
No, we'll do better than that.
And this is something you want to look at in the summertime when it's overhead, not
Yeah.
now when it's setting. I mean,
But the dark of the moon is right now, so that's an
yeah,
opportunity.
yeah.
See here.
Somebody at Astronomy Magazine desperate for an article.
I think they reuse articles.
Yeah.
I was looking at this and the comment that you on a 4 or 6 inch scope could see
Yeah.
it. I started thinking, boy, that'd be a good thing for my little 6 inch mirror some night, in summer to try and see what I could see in this.
Yeah,
You really got to have a dark sky.
right.
Yeah.
On Friday, Tim, you had your little scope pointed this way,
Yeah,
but it
yeah.
didn't look like that.
Nope, nope.
So you can see this okay?
Yeah.
Mhm.
Okay.
Real good.
So this is the North American Nebula, NGC 7000. This is the Gulf of Mexico. This is Central America going down there. And then over here is the Pelican Nebula with the head of the pelican. It's quite an appropriate name.
Boy, that's really amazing too.
Yeah, look at his eye. It's pretty neat.
Yeah.
Mhm. His eye is very dark.
And all that pink is hydrogen?
Yep.
All the
Mhm.
red stuff, yeah. The blue too, not the blue, the black too, but the black is sufficiently far away from a star that it's not illuminated or it's not irradiated to be active.
Mhm.
Well, a basic chemistry question, please. Hydrogen is one proton, one electron. Are they all built like that? Is it atoms that make that pink, or can there just be single protons waiting for an electron? Can
You got to
protons
have the
still,
electrons jumping around to see this glow.
Right.
is that right? Jumping from one to another, but they
Yeah.
still keep.
As if I remember correctly, the red glow of hydrogen, hydrogen alpha, is jumping from the third orbital to the second orbital.
That's right. That's right. Down to the second, Jerry. You're
Yeah.
right. Mhm.
Huh.
If you go to the first, we can't see it.
Yeah.
But to get
Now, there-
helium, you need fusion.
There is a line that neutral hydrogen emits that is at
Yeah.
21
Radio.
centimeters, which is
21 centimeters. Yeah.
way out.
Can't,
What's that?
can't see that either.
No, 21 centimeters. No, that's way outside the visible. But
Ronnie, there was helium created in the Big Bang also. Hydrogen
yes,
and helium.
and a
Just
little bit of
lithium didn't
bit of
get created.
lithium.
Lithium and a little bit of beryllium.
Okay.
That's the only way the protons are going to get together.
I
And the
think
nucleus.
I've also wondered this. Why red? Why
Well,
the
that's
red
the
color?
energy level of that jump.
Yeah. And
Well,
red is a human perception of it.
Okay,
Okay.
but if it's added to or missing neutrons, it becomes an isotope, right? Or can it be a
Yes.
normal
If you
without?
add, yes.
You have
Okay,
to add neutrons.
Then you can't take away neutrons from hydrogen. Doesn't have any.
it never has any.
But if you add one, it becomes deuterium. And if it makes water molecules with deuterium, it becomes heavy water.
Add another
Or
one. It's
tritium.
tritium. Tritium. You add another one.
Tritium's
Oh.
unstable though.
13-year half-life.
Okay.
Yeah.
Well, I just learned what hydrogen peroxide was, and I sometimes swish my mouth with it. It's hydrogen 2, oxygen 2, isn't it?
Yes.
Yeah.
Mhm.
So an extra oxygen atom makes it poisonous.
We
like Just like
yeah,
CO1.
our dog one time ate a medication and we called our vet and they said you have to make her throw up. And they said, how do you do that? She said, give it 2 tablespoons of hydrogen peroxide.
Yeah.
I thought, remembering all the times we'd have trouble getting medication down our dog's throat, I went over to her with a tablespoon full of hydrogen peroxide, and to my great surprise, she loves hydrogen peroxide. So we gave her 2 tablespoons, and she just walked away, and all of a sudden, blip, there it was.
Yeah.
Now, this is a telescope that when I was a kid was called the 48-inch Schmidt camera on
Mhm.
Mount Palomar. It's 48 inches in diameter up here, and it's a Schmidt camera. It has a corrector plate. It has a 72-inch, a 6-foot diameter mirror back here, and about here, you can see there's a window. They put a photographic plate in here. There's no provision to make this a telescope you can look through. And when it was first used up till about 1991, I think, these 2 10-inch refractors were used to visually track stars,
Wow.
to take pictures. And the plate was 10-inch by 10-inch glass plates that had to be curved to fit the curved focal plane.
Hmm.
So in the 1990s, they changed it over to a CCD, and these things are now run automatically to guide. So it's a very very nice scope. Takes
And
very
that's
wide field pictures, and it took the picture of NGC 7000 that we just looked at.
yeah. And it's very fast.
Yes, I think it's F2 or something, or F.5, some, not can't be F.5.
And
that's
until Vera Rubin.
That's probably when it got renamed the Ocean scope too.
Yes, that I forgot to mention that.
Was that the
Samuel
biggest?
Ocean, and I don't know who Samuel Ocean is.
Huh.
But he must have given a lot of money to various astronomy things around California because
Yeah.
it used to be the Ocean Planetarium at Griffith.
Oh, okay. Yeah, this telescope was built in the 1930s.
I'm sorry, but it doesn't look like a telescope to me. Looks
You
like a
can't see the
gun.
back end,
Oh,
but here's a classic fork mount.
Yeah.
There's the polar axis right there, and then here's the declination axis going in there.
oh, I see. It's an angle away from this thing. Got it.
I forget the lady astronomer's name, but it's in the caption on our talking points.
So you suppose that was the largest camera until the Vera Rubin?
No.
Yes, I think so. It was the wide field camera because you could still use the 100-inch telescope and the 200-inch telescope as a camera. But it's the widest field of view until the Vera Rubin, I think.
Well, can I ask a quick question about modern day cameras? Is it all pixels in a row, whereas in the old days of silver, there was no pixels?
No,
That's what the silver was.
yeah,
Silver was pixels?
it was a chemical called silver halide, and they were molecular sized. So it was like a pixel, but they were in a solution and they were randomly spread over the plate. And when a photon was absorbed by the silver halide molecule, it produced a latent image that then you use chemical to bring out and change color.
Okay. Did they line up like pixels in a row?
No, they were randomly distributed.
But television has always been pixels, hasn't it?
Television is a raster scan. It's not, it sort of has pictures, but they're time designated pictures.
Pictures or
As,
pixels?
Pixels.
as the electron beam scans across, it changes its intensity in little steps.
Okay.
Anyone have anything to add?
I guess the Rubin,
When you get to the picture, I'll mention something.
Okay.
okay. Fascinating when I learn if I could just keep it.
Okay, anyway, this is there is a small and narrow meteor shower that really happened yesterday over the weekend called the Ursids. The radiant point they come from is right here in Ursa Minor. There's Polaris, we were just speaking of it. The star Kolchab, the brightest star, second magnitude, also like Polaris. It's right next to that. So you want to look over here or over there around, because if you see a meteor coming here, it'll just be bright, no length to it, and it'll go out. It's a small thing. It doesn't produce anywhere near the number of the Geminids did last week.
If on spaceweather.com today, there's an all-sky fireball network across the US that NASA runs.
Okay.
And they show a little diagram of the fireballs that were seen, and there were like 22 that they saw from this event. So
Wow.
those would have been the big bright ones.
Yeah. And here's my comment, Jerry. You see the fuzzy little tennis ball up there above Polaris, the yellow thing? Right there. That's Caldwell 1. That's the furthest north open cluster you can get in your telescope.
Huh.
Yeah. Have you seen it, Chuck?
No.
Okay. I think it's Caldwell 1. I've seen it in a small scope.
Okay. So you can tell from the offset from the North Pole, Polaris, that's about 1 degree. So this is 1, 2, 3, 4, 5, about 5 degrees or 6 degrees up there.
Easy to find, thanks to
should be.
Polaris.
Furthest north?
Well, it'll go around.
Yeah. North is toward the center.
So it's close to Polaris?
Yeah.
Yes.
There's
Oh,
Polaris.
There's Polaris right there.
Oh. Well,
You can see the little dipper goes around and around and around, Ron.
Yeah.
And that's Draco. You see down there, Draco. And Tim and I could only get the head, and we tried to find new Draconis for the folks on Friday, and I couldn't remember which star it was. So
that was tough.
yeah.
So
Because you don't get the whole dragon right now.
Okay. So a star hop would be going the last link of Ursa Minor and then about 90 degrees to the left in this orientation.
Does anybody in science know the name of the comet that left us this debris that's giving us these meteors?
That I looked it up, I didn't find anything.
But does that mean the comet disappeared in that direction into that particular constellation that gives us its name, or might it have just passed by and somehow
Yeah,
they come from?
it passed through this area to leave a debris cloud there, although the debris clouds can migrate a little bit.
Yes. But this apparently, because it's a very narrow time frame to look at it, the degree, the dispersal of this is not very big.
Hmm.
So either there wasn't much of it or it happened just recently. Okay.
Another part of the sky.
This is the Virgo cluster up here. And you can see Coma Berenices here, and this, it's easy for you guys to see, but it's hard for me to see on this. Anyway, here's a bunch.
This is early morning.
All the
Yes,
yellow,
this is-
all the yellow stuff is important.
This stuff
Those are
will be
messy
overhead
objects.
about midnight in like March.
Hmm.
And this is the path through which, passing by things like M98 and M99, zipping along, is comet
Showmassa.
Yeah, good luck.
Yeah, what he said.
Joe Massa. Joe Massa.
And this is the path it takes through. This is Leo here. So up here on 1210, where we're about in here.
Yep.
So the Virgo cluster is down here, and this is passing through the upper regions of that, heading over here, and then retro motion.
Yeah, that bright star at the end of the Lion, it looks like it's going right by Denebula.
End of the Lion.
Yeah.
And that's near where 3i Atlas is right now, except I think it's going in the other direction.
Okay.
Oh, interesting.
That reminds me of a puppet show I used to watch in the early 50s, Cecil and Beanie and Cecil. And they had a character on there about Terralong, the dotted lion.
Cecil was a dragon, wasn't he?
No, there was
serpent.
Cecil was the C6 sea serpent.
Oh, a suit. Okay, something like a dragon. And all right.
There you go.
But Tom cracked a joke by claiming this is the end of the lion here.
Well, the see the bright star near the 1230?
Yes,
That's Denebula. That's the very tail of Leo the Lion.
right.
Denebula or Deneb?
Denebula.
Denebula, a little tail, literally, in Arabic.
Or if you're real contrary, Denebola.
Yeah.
Well, is there something different out there called Deneb?
Yes.
Yeah, there's
Yeah,
Deneb.
and Cygnus the Swan.
It's
Now, this
Arabic
is
for
the name of
tail.
the comet, 24P Shalmassa. Shalmass?
Showmassa.
Yeah.
German guy discovered it.
Now, I'm
again.
assuming this is a photograph taken by an amateur, and he's got a lot of camera information up here. I know ASA 2600, focal length 400 millimeters, so it's a telephoto lens, but he doesn't give the camera type, the body or anything. So, and I looked in the article and didn't find anything. So, but it's a nice photograph, fairly wide field of view. He did obviously track on the comet.
God, everything's up there on the top.
Well, the ASI 2600 is the camera.
Is that, I thought, oh, that's right. It would be ASA.
Yeah.
Oh, you're right. I got to stop doing these things late at night.
With a cuckoo clock.
Yeah. I need that cuckoo clock. Okay, this is the measured and predicted brightness of Comet Chumash. Right now, here it's going to peak. It's projected to peak in brightness on the January 1st, 2026, at just below 8th magnitude. And so it's always going to be a telescope object.
Yeah.
Right now, it's about 11th magnitude.
Hmm.
So these are observations, and this is projection. And I don't know what this axis means, but we can figure it out. I don't speak Japanese.
But a question about containing or connected to the meteors. If this crosses our orbit somehow, we're going to get a new shower every year, aren't we?
Yeah, yeah.
So
Well, this comet isn't particularly new.
No, it has a period of 8 years. And it's got a P in there, so it's periodic. So we're going to see it again.
Haley's is what, every 78
Yeah.
years?
Now this
76.
software, this
76.
software thinks this is the last one, so I'm going to switch.
All right. There are our 5 ugly faces on screen instead. Please bear with us, folks. Get to the beauty of the night sky here again. There we are.
Wow.
Switching comets here. This is 3I Atlas, taken from Gemini South, I believe, telescope. That's an 8-meter telescope. So this is a very good look. It's about 40 million miles away. The
40 or 140?
You're right, 140. It's about Mars.
Yeah.
So you have to subtract 90 from us. No, I think it's 40 million.
Mm.
Wait, it's in my notes.
Well, Tim, look it up quick.
Oh boy.
If this leaves the solar system, it'll lose its luster and the brightness will go away and it'll just become a rock again, won't it?
Or an ice ball, really.
All that ice in between solar systems.
Oh, we covered that distance so many times that I didn't put it in here again.
Yeah. Yeah, it never got closer than Mars to us. So
That's right.
I actually got an image of this the other night, but I haven't had a chance to process any of it.
Oh, okay.
And it's in FITS files, so I have a harder time processing it. But it was a little fuzzy blob.
Yeah. It has now passed its closest point to us and is now speeding away from us or beside us. The news has strange adjectives to describe this comet and what it's doing.
Well, yeah, I've probably asked this before, but are they rare? Is this the third one that we're aware of, or do they suppose they're coming through all the time? Hundreds, thousands of them. We just miss them.
They're not hundreds or thousands, but there's no reason to think they're super rare.
Right.
But there's all kinds of stuff out there in space, rogue planets and rogue black holes and rogue comets.
Yep.
We only have the technology to decide that they are extrasolar in the recent years, and we've seen 3 of them in the last couple decades. So I'd say we get about one of these a decade, extrapolating the meager data we have.
No plans to go send a probe to one to see if they're made up differently than our.
There definitely is. There's a probe sitting out. Yeah.
They're going after this one, or they're going after Oumuamua, or what?
I think no. Oumuamua is too far and too fast, and this one is too. But there's a probe waiting for the next one. As long as they see it soon enough that they can redirect the probe to it.
Right. When these things come in from interstellar space, they are really hauling. Normally, comets do around 35 or 40,000 miles an hour, some of them up to 60. But these things are at least 50,000 miles an hour or more. They're hard to catch up with.
But Oumuamua was not glowing like this. It didn't have a lot of water, or we wouldn't have known it was long and cigar-shaped, would we?
That's because it was tumbling and you could see the brightness change.
Oh, really? But it was emitting haze and...
Yeah, but not a lot. And it seemed to be emitting hydrogen. So it was like hydrogen ice or something like that. Hydrogen and nitrogen, it was a different composition. It seemed to come from a Pluto-like thing. So a lot of nitrogen and hydrogen.
Okay. Now this picture was taken by the Virtual Telescope Project. It was taken by a 250 something Artec.
Probably millimeter.
F4.5. I don't think that's meters.
So that's like 10 inches.
Yeah.
Millimeter.
Yeah. And on a software Paramount or on a software BISC Paramount ME Moravian mount. Excellent mount.
The best I could find was 140. They mentioned from the sun, the closest was like 160 million miles.
Okay.
So
So from us, well, we might not be in the same line, but
yeah,
track
I couldn't
90.
find it in the notes, but
Okay. No, I couldn't. I forgot to put it in there. So this one, Chuck's probably right as usual. This is a picture of 3I Atlas in X-ray.
holy mackerel.
This is a long exposure. It's not real high resolution. The key thing here is that it gave us spectral data. And this is another picture from a satellite, an X-ray satellite, an image, a higher resolution image, but still not really dramatic, of the satellite, of the comet 3I Atlas in X-ray. These X-ray telescopes are very tricky to use and expensive to build, and Tom Whittemore, I think, is an expert in that. But we'll have a little segment next week about X-ray telescopes.
Does the black line mean anything through the middle of it?
Yeah, the photons are missing from that. But other than that, I don't know. Could be two pictures put together.
Yeah.
Wow. Colorful.
Yeah.
And just as an aside, there's an image also that was taken by SphereX. And
Yes.
wow, SphereX is all over the astronomy news these days because they just finished their first full composite.
Yeah, I almost included that this week, but I had so much other stuff.
If it were to pass over, it'd be going south to north or north to south. Because it was
Well, it was in the plane of the ecliptic, Ronnie. That's one of the things that was odd about this incoming 3I.
I'm talking about SphereX.
Oh, SphereX is it's on the ground. It's a telescope.
No, it's a satellite.
Oh, is it?
Yeah, that was our speaker at the
Oh,
last.
that's right. I'm mixing it up with the ground-based repeat of the cosmic microwave background image.
Oh, yeah.
Sorry. Anyway, this red dot here is Ceres, and it's currently located just south of Pisces in Cetus, the whale. And
about a 300 mile diameter rock.
I think it's 600.
And it's ice.
Really? It's all ice.
Not all ice, but it's ice.
Yeah. Now we did send our Dawn satellite there to orbit both Vega, not Vega. What's wrong with me today?
Ceres and Vesta, I think.
Vesta, thank you.
That's the
Number 2 and number 1. And this is Ceres. And you see it's always got even though you can't resolve it, you can see its brightness significantly change as it rotates. And that's because it has these really bright white deposits on the surface that even though you can't resolve it, you get so much brightness from these things that you can pick them out. And so it gave us a good rotation rate.
That's just not the way ice looks.
This is the crater on
okay, got
Ceres. And these are,
wow, that's a great image.
yeah, these are from Dawn. And these are deposits from geysers, which apparently there is an underground ocean of salt water. And the water came up in geysers, the salt was deposited here and the water sublimed away. And then there's a frozen mountain that got pushed up, looks almost transparent. I didn't include that in the photos this week, but it's very dramatic.
Frozen mountain. Wow. Well, on Pluto, the big heart-shaped white is all nitrogen, isn't it?
Yes, it's frozen nitrogen, solid nitrogen.
No, what
This is not solid nitrogen. These are salt deposits.
Oh, salt.
So what is the material here and around that? That's not ice, is it?
Yes.
Megalith.
Really?
That's ice with some other, dusty stuff mixed in.
Yeah.
And then the really bright stuff is the salts.
Yeah.
Oh, God.
Huh.
And this is a size comparison
Ah,
of Ceres, the
got it.
moon, and the Earth. So this is about 600 miles. This is about 8,000 miles. What's this about? 2,000?
2,160.
Okay.
Maybe Vesta is 300 miles. There's one that's I read it was
Yeah, I think
300.
Vesta's that. Vesta's not quite spherical.
Oh,
Yeah.
So that this is Vesta is an asteroid. Ceres is numbered as an asteroid, but it's officially a dwarf planet
hmm.
because it's round. And it doesn't have any other things around it that aren't orbiting it.
These definitions get really, really.
That's a really lame definition that they chose. Yeah.
Yeah, I second his comment. Okay.
That's when I wanted to go. I wanted to see that Christmas tree cluster the other night at
Here it
night.
is. There's the Christmas tree cluster and the Cone Nebula and Hubble's Variable Nebula, very rich region of the Milky Way going right through here. There's Gemini, and this is about 2 a.m. and Orion, the winter constellation, is up. I don't know how close the horizon is.
It's
But
up
there-
pretty good by then.
Yeah, it's up what about 27, 30 degrees?
Mhm.
Oh, at least, yeah. By 2 a.m., it's way up there.
Oh,
Yeah.
okay.
And Jen was showing the Christmas tree cluster.
Was she? Oh
Yeah,
man.
in the 8-inch up there.
One night I found the Hubble's Variable Nebula because I was after that. That's the first image that the Hale telescope ever got.
Mhm.
But finding it's a little bit more difficult, even though you can probably go through Bellatrix and Betelgeuse on that line, but it just doesn't work. It's kind of hard to find.
It's small.
Jen is a reference to Professor Ito at Westmont College.
Yes.
Professor G these days. She got married.
Oh, she did? I didn't know that. Sorry.
Yeah.
Whittemore, any comments?
No.
Okay.
Okay. Okay. Can you spot the cluster?
It's a little blown out, but it's upside down.
Oh, sorry.
Kind of
Yeah,
bright.
it's upside down.
Must be a sea star image.
Somebody can tell that a piece of sky is upside down. Man, oh man, you guys
Well,
are,
the Christmas tree asterism was upside down.
oh, so it doesn't look like a tree then. Looks like a Dixie cup, maybe.
Damn, I keep opening the wrong program. Okay, open with Office.
In other words, we're closing out with all the Christmas stuff in the night sky.
Yeah.
Yep.
Okay, good.
There it is.
Now,
You're amazing, McPartland.
this is the cluster here. There's the base of the tree. There's the stand. It's upside down. There's the tree going this way. And then up
Oh,
here,
okay. Yeah.
and there, and this is the Cone Nebula.
Oh, nebula, yeah.
Yeah.
Or
the
Madonna
entire-
and Child. Madonna and Child, sometimes called.
Okay. Yeah, there's two heads there. Now there's
Huh.
There's another Christmas tree,
Yeah, 103.
103.
Yeah.
okay. Now
That
NGC
was an easy
2264 refers to this entire complex of nebulosity and cluster.
Boy, Tommy, we should have tried that.
The nebulosity wasn't showing, when Jen showed it in the 8-inch refractor in the big dome. The
Yeah.
nebulosity didn't show at all, but you could see the Christmas tree cluster pretty well.
Yeah, I've got to try that. I've really got to try that out. It'll be here for a while, so I'll do it.
Mhm.
Well, I'm sure none of these Christmas trees were popular among the old Arab Muslim.
No,
soldiers.
they weren't visible either.
Oh, they
You
weren't?
know, Ronnie, one night we were out and Cygnus was up, and I mentioned Deneb, and some Arabic people were nearby, and I mentioned Deneb, translated to tail, and the woman got really excited, and she says, "That's right. That's right. You're." She goes, "That's really cool." She got really excited. She didn't think that I knew that, and I didn't. But I got it from the Chuckopedia.
Well, a lot of these names really got corrupted from the Arabic because they get copied over and over by monks and scribes.
Yeah.
Yep.
It was like a centuries long game of telephone, and some of them are really corrupted. And you say, well, this comes from an Arabic phrase that means blah blah blah, and people who speak Arabic look at you going, huh?
Yeah, yeah. It's really kind of neat. And someday I'd like to get a collection of that stuff. And then when I go out with Tommy, he's really good with language, and so it's really near when he's nearby, and we're looking at all these clusters and stuff and the names. It can be fascinating, especially for some groups of people.
So for those ancient Muslims, if they had a dog, it was often seen wagging its denib.
Yep.
Or Denebola.
Yeah.
Okay, well,
If it's a little dog.
okay.
This is a picture of NGC 2264, the cluster and the nebula, taken by the Spitzer Space Telescope, so it's in infrared.
Good
So all the
grief.
bright visible stars are missing from here, visible band, and we're looking at cooler stars. The Cone Nebula is here, and there's the child of the Madonna is there, and this one is the angel on top of the cluster, but the rest of the cluster is disappeared in here.
This is also a wider field, though, so the cluster ends right there near the middle.
Right there.
Yeah. Yeah.
Yeah, this is the pot holding tree at the bottom.
I'd call that one the shrimp nebula.
Yeah, it almost looks like a scorpion, huh?
Yeah, or scorpion, but that's taken, I think.
No, I have to say that this looks like a cat that you've just taken out of the bath and it hasn't had its hair dried yet, and it's all fuzzy. And there's its face and its nose.
Yeah.
Too much.
Okay.
Christmas.
Oh,
What is this?
somebody here disagreed with you.
Someone, oh yes.
This the ornament of the sky, I assume.
This is a picture. This wasn't in your talking points. I edited it later.
Got it.
This is a picture of Fomalhaut, and that's the dust ring around it. This is an earlier photo, before the talking point. These are before photos. And then this is an orbit of a planet, Fomalhaut B, that they've decided is there sometimes and it's not there. And we're going to discuss why it's not there. So
Really? In a future program?
No.
right now.
Oh, right now.
Yeah.
Are those two circles, the one oval for the planet and the dust ring, are they in the same plane?
This is, yes, I think so.
Wow.
This is the main belt gap and the inner belt. These are all the belts have been mapped.
And those are like asteroid belts.
Yes, main belt halo. Someone is got nostalgic for Saturn, and they're trying to find all the rings and gaps and everything.
Yeah.
So anyway, this is Fomalhaut B. This is the star Fomalhaut, which is a very young star. It's only a few 100 million years old, and it's going around this way.
Exoplanet.
And,
Well,
is
they thought.
what
They thought exoplanet.
yes, that was and that was an earlier article that confirmed the planet. So because they got an orbit for it. So now this is an artist rendering of what happened to that planet. Right
Really?
here in the inner ring of the dust planet, the planetoids, the planetesimals collided. So it's very rare to see something on the scale of pre-planets colliding, but they think they got it. And these are the particles now, CS1 and CS2. These are the particles separating. They're both up here in the inner band. These are the two collision.
Debris clouds, basically.
Yeah.
So it's not like Saturn's rings, mostly ice. This is dust?
Probably
Chunk?
both.
Yeah,
What is a planetesimal?
Something smaller than a planet,
yeah. It's a planet part.
like a
Okay.
big asteroid.
Okay, but it's not spherical then.
Could
It
be.
doesn't have to be. If it's big enough, it'll be spherical. If it's not, if it's small enough, it'll be like Vesta.
Okay, unless I missed something. You said two of them collided. One of them stayed a planet or a.
No,
No.
no. So they thought they had found an exoplanet, but what it was this collision, basically, in an earlier stage where it was just one big cloud of stuff.
Okay. Did the collision leave the ring?
No, the ring was there.
These
The
are
ring is
collisions
there.
in the ring, just like Theia collided with Earth in the early solar system.
But chances are rings were planets at one time.
No,
Oh, they're going to be planets.
Oh, they're going to be planets.
they're
Oh,
building blocks, not debris.
I see.
They will go through a process of smashing together, and if they're hitting fast enough or hard enough, then they'll fly apart with a lot of debris. If they're going slow enough, then they're big enough, they'll stick, and they'll start forming a planet.
Huh. So this is different from the way they think our moon was created. Something hit the Earth and became one of these, and then that coalesced into the body we now see as the moon.
Only in detail. This could be a future moon for this. Who knows? Well, of course, that's quite a long distance, but
Yeah.
I just don't understand the two things in the square at the lower right you're talking about. Are those two pieces of dust?
this is the cue ball. This is the 7 ball, and this is the cue ball.
Yeah.
Oh,
But they're pretty much clouds of debris now after
Yeah.
colliding.
Right.
And we can see these, or we have some
Yes.
sort of a
Yeah,
telescope?
you're looking at a picture of them, and then you take a picture later, and they're moved. So this picture was taken in 2012, and this picture was taken in 2023.
Okay, but of all the thousands of exoplanets they've nailed, they don't have any except this theoretical one around Fomalhaut.
No, it's gone now.
Yeah.
Oh, they don't, so it doesn't have any exoplanet.
We don't know for sure.
Yeah,
Just
no,
the
these are
ring.
these are exoplanets.
Well,
Exoplanetesimals.
exo debris, yeah.
Yeah.
Is the star like a sun size? Is it like ours? In which case that ring might be what, the orbit of Saturn or beyond?
I think this is a little more massive than our sun, but not a whole lot.
can I just interject? This is an aside. Last night, this came up, and you're skirting the topic a little bit here. Somebody asked me when we're looking at exoplanets, and they were talking about, well, how can we see them? And I said, not all the time. You're going to know because of the gravitational perturbations. But they also want to know, how do we know what they're composed of? And I said, well, it's a spectrograph of light that reflects off them.
And passes through their atmosphere.
That's
Yeah,
the thing.
you get both reflection and you get transmission when they transit in front of their star.
Huh.
Oh,
You can take a spectrum of the star when the exoplanet is behind it, and then a spectrum of the star when the exoplanet is in front of it, and you subtract those two, and you get the spectrum of the atmosphere of the exoplanet.
oh, wow. See, I didn't have a good answer for him. That's a great answer. I love that.
I do recall seeing some other stars in past programs that had some sort of rings around them, but this is a rare occasion, right? This rarely happens with stars that they get
No.
rings like Saturn, or is that
No.
common?
No, it
No
seems to be
what?
fairly common.
Yeah, it's a stage that it goes through. It's very rare that we catch an actual collision that we see it.
Oh, I see. This is the beginning.
Yeah.
The swirling. Okay, got it.
Okay. Fomalhaut is a bright white hot star. It is much brighter and hotter than our sun. It's 25 light years from Earth, one of the brightest stars visible from Earth, 18th brightest, including the sun. And let's see.
And the name comes from mouth of the fish.
Yes.
And I never find it.
Yeah.
People ask me, what's that up there? And I said, hang on, let me go ask the Chuckopedia.
But it's often called the lonely one too. It's the only first magnitude star in that part of the sky.
Okay.
And it's definitely Arabic.
Yeah.
Fomalhaut, mouth of the fish.
Hmm.
Yeah.
They had a name for the mouth of a fish.
Yeah, that's interesting.
It's the bright
Well,
star in Pisces Austrinus, you know.
it's
Oh,
multiple words, Ronnie. It's not one word.
yeah.
Oh, okay. We're pronouncing it right? Fomalhaut.
So
I say
Fomalhaut, the triple
Fomalhaut.
star system.
Jerry says Fomolo, and a lot of us say Fomalhaut.
Fomalhaut. Yeah,
Well, I've
Wow.
had French.
it's not French.
Arabic is a
No,
language.
there used to be a radio show that I'd accidentally come across from McDonald Observatory, and they called this time of year the Fomalo hour. So I just picked up their pronunciation.
Yeah, works for me. It's fine.
And that's because that HAUT
Yeah.
is similar to the French word for something like height.
High. Yeah, like Terre Haute.
Yeah.
Fomalhaut. That's
High
very
country.
Haute,
Yeah.
Haute, Fomalhaut,
Yeah, Tim, Fomalhaut.
So
Fomalhaut.
Meta claims that this is a K-type main sequence star.
Yeah.
J-type. So they still use these words that they've designated stars as during their normal everyday conversation in Arabic countries, you suppose?
I imagine so. I mean, these are
How
the
often do you,
official names.
Yeah.
how often do you get to say the mouth of a fish?
You just did.
I know,
Yeah.
but I've never
When you're
said that
talking
in my
about a
life.
constellation that's a fish,
It's a fish.
and
Yeah.
that star forms the mouth of the fish, that's what you call it.
I don't think we have an English word for the mouth of a fish.
What
Well,
about
also,
what about
also,
Kauda and Kaput?
Yeah. And
I'll put it.
it's not one word, Ronnie. It's three words. Mouth the fish.
Right.
All is the.
So
Mhm.
foam would be the mouth.
Yeah.
oh, I'm done.
Okay, interesting stuff we learn on this program.
What would in Orion? What do they call the fish mouth? Could we be calling that Fomalhaut?
That's not something anybody would have seen in ancient times.
Okay,
There's a fish mouth in Orion.
yeah.
Yeah, the little dark cloud that comes
Right.
into the
It just
nebula is
looks
called the fish's mouth area.
right. Looks like a fish's mouth.
It
Yeah.
goes. I think it goes into the trapezium, if I'm not mistaken.
Toward the trapezium.
Yeah,
Yeah.
towards it. Mhm.
Can you see it from where we set up for the star parties on the
Oh, yeah.
second Saturday?
Oh,
You
With
can
a
see it?
telescope, yes.
Yeah.
Oh, then I'm going to go look at it. Doggone it.
You can
Yes,
almost pick it off in binoculars, Ron.
well,
Okay.
listen, we're
Almost.
past our top. Anybody want to sum up anything? We mourn the loss of our
just say
good
we
friend
miss you,
Bruce.
Bruce.
I'm willing to let the president let everybody else know. But
Yeah. Yeah, we'll
Yeah,
have a
Jerry,
eulogy.
if you have an article, please let me know.
Can you guys hear me?
Yes.
Yep.
Yeah.
Okay, we'll have a eulogy next week for him that we write. And we miss Bruce very much.
Yeah.
And we're sorry for Bonnie and her grief.
yeah, I like the man. I really did.
Yeah.
Okay,
And
Great
I
guy.
like you, gentlemen. There's 5 of us until we get a 6th or replace him. But Merry Christmas and Happy Hanukkah, everybody.
yeah,
Yes.
Dr. Martin will be speaking to us in 2 Fridays. In the meantime, I guess we're going to meet back here next Monday in between holidays, right, Mr. Prince?
yeah.
Yeah. Mm-hmm.
Okay, then on that note, how do we say goodbye in Arabic, Art?
Asta Nebula.
Nebula works for me.
So
Thanks,
it's in
Ken.
you.
Goodbye, everybody.
Thank
Appreciate
you.
it.
Bye, Jerry.
One at a time.